Hi class, so this will be the continuation of our discussion about the sample problems of equilibrium of concurrent force system. So let's continue our discussion. Now let's proceed to sample problem number 3. So a 300-pound box is held at rest on a smooth plane by a force P inclined at an angle theta with the plane as shown below. If theta is 45 degrees, determine the value of P and the normal pressure N exerted by the plane. So we have here a box. Okay, so this box is 300 pounds. So its weight will be applied here in the center of gravity or the center of this box now, which is somewhere here. And our force P, it is applied this way, and this is 45 degrees from the inclined plane. Okay, and also class, this box, okay, aside from this force P, okay, so this is also supported by this this surface, no? So um, this is supported also by the surface. So this will produce, or this will provide a normal force and here, and it is applied at this point, no? So this is also the center of the point of contact, no, of this box and this plane. So it will be somewhere here, and it is applied perpendicular, no, from the incline. Okay, so from that, no, so we are going to solve this. Okay, so again, we are asked here to solve for the force P and the normal force N. So let's first draw the free body diagram of our box here. Okay, so for the free body diagram of the box, okay, so again, this is the box. So this is the 300-pound weight, no? This is applied here, and your force P is here, and this is 45 degrees from the horizontal. And if we are going to extend its line of action, so it will pass through, okay, the center, no, of this box. And also for this normal force N, okay, so again, this is directed at this point. So this is the center of the point of contact of the box and the surface. And this is applied perpendicular, okay, to the inclined surface, no? So if we put a vertical line here, its angle from the vertical is 30 degrees. Okay, so this is 30 degrees from the vertical. Okay, so we are going to analyze the angles for this, no? So if this is 45 degrees from the incline, so this is that 45 degrees. So meaning to say, this angle, no? So this line, okay, is actually parallel to this incline. So this force P is 45 degrees from this incline line, no, parallel to this incline. So this is also 45 degrees here. If this is 45 degrees here, so this is also 45 degrees here. Okay, so if this is 45 degrees here, okay, so as we know that this is 90 degrees, right? So this line and this line, they have 90 degrees angle, no? So if this is 45 degrees, so this remaining angle, this is also 45 degrees. Since 90 degrees minus 45 degrees is 45 degrees. Now, we need the angle of P either with respect to the x-axis or with respect to y-axis if we are going to solution 1, if we are going to use solution 1. Okay, so we can actually solve for the angle of P with respect to the vertical axis, no? So since our normal force, and if we extend this, so this will be the line of action of our normal force, and so this line, okay, this line, so this is 30 degrees from the vertical. So since this is vertical, okay, so this angle is also 30 degrees, right? So this angle plus 45 degrees, so that will be the angle of P from the vertical, from this vertical line, okay, or vertical axis. Okay, so this will just be 30 plus 45, so that will be 75 degrees. So this will now be the angle of P from the vertical axis. So we can now start using solution 1. Okay, so using solution 1, that is summation of forces horizontal is equal to 0. So positive for forces directed to the right. Okay, so we will start with force P. So the horizontal component of force P, okay, with respect uh, to the conventional x and y axis, no? So this is P sine 75 degrees, no? Since our angle is from the vertical. Okay, so the horizontal component of P will be P sine 75 degrees. Okay, since it is directed to the right, it will be positive here. Now for normal force N, so the horizontal component of normal force N is N sine 30 degrees. Okay, since our angle here is from the vertical, no? So it is directed to the left, that's why it's negative here. Okay, so those are the forces that have a horizontal component, and it will be equated to 0, and this will now become our equation 1. Now for our equation 2, so that will come from summation of forces vertical is equal to 0. Okay, so positive for forces directed upward. So we will start with P. Okay, so our P is actually directed downward to the right, right? So this is downward to the right. Okay, so downward to the right. So its horizontal component, vertical rather, its vertical component will be P cosine 75 degrees, and it is directed downward. So this is directed downward, so it will be negative here. Now for our normal force N, so its vertical component will be N cosine 30 degrees. Okay, and since it is directed upward, it will be positive here. And our 300-pound force here, this is directed downward, so it will be negative here. And this is already vertical, that's why it will just be directly included here as 300. And this will be equated to 0. So this will now become our equation 2. So we have here two unknowns and two equations, so we can solve this either by elimination or substitution. So we will use substitution here. So we will generate the value of P from equation 1. Okay, so this is the value of P in terms of N. So this is N sine 30 degrees over sine 75 degrees. Okay, so we're going to substitute this value of P to equation 2. Okay, so in equation 2, we have here force P. So we will substitute this P here. Okay, so substituting this, so this will be negative, and your P is N sine 30 degrees over sine 75 degrees times cosine 75 degrees plus N cosine 30 degrees minus 300. And this will be equal to 0. Okay, so we can notice here that only N is the unknown quantity. So simplifying this further, so sine 30, N sine 30 over sine 75 times cosine 75. So that will be negative, since we have negative here, so this will be negative 2 plus square root of 3 over 2n. Okay? And then we have here cosine 30 degrees n. So that is square root of 3 over 2n minus 300 is equal to 0. So combining the 2n, so this will be negative 2 plus square root of 3 over 2n plus square root of 3 over 2n. So that will be negative 1 plus square root of 3n minus 300. Okay, so solving for n, that will just be 300 divided by negative 1 plus square root of 3. So that will be 409.81 pounds. So this will now be the answer for this. Now for the value of P, we just substitute the value of N obtained, okay, to our formula here for P, okay, to solve for P. So that will be 409.81 sine 30 over sine 75 degrees. So this will give you 212.13 pounds. So this will now be the answers for N and P. Now here we can also use our second solution, which is the rotation of axis. Okay, so from our free body diagram here, so we will redraw this, okay, this way. So again, this is our P will be it can be extended, no, and also our normal force, and so it can be extended, and they will meet at this point. Okay, so from here we will again, your P is 75 degrees from the vertical, and your normal force N is 30 degrees also from the vertical. Okay, so to solve this using solution 2, okay, so we are going to place one of the unknown quantities, okay, or unknown forces to one of the axes, to one of the new axes, no? So in this case, we're going to put x-axis, or we are going to put normal force N to the new x-axis. So if this is the new x-axis, so this perpendicular axis will be the new y-axis. Okay, so from here, no, again, your N is already in the new x-axis. So we have to solve for the angle of 300-pound force. Now we have to solve for its angle from the either from the vertical axis or new vertical axis or new horizontal axis, and also for P we have to solve for for its angle from the new x-axis or new y-axis. So in this case, we have here for P. Okay, so as we know, our P is 75 degrees from the vertical, and as we also know that this is 45 degrees, no, from this incline. So this incline, okay, is actually the new y-axis, right, for this solution, no. So if this is 45 degrees here, this will also be 45 degrees here. And if this is 45 degrees and this is 75 degrees, since this is a straight line, this will have a 180 degrees. So to solve for this angle, so this will just be 180 degrees minus 45 degrees minus 75 degrees, and it will be 60 degrees, right? So this 60 degrees, this will now be the angle of 300-pound force from the new y-axis. Okay, so also for force P, okay, so as we know nga, no, this force P is already 45 degrees nga from the new y-axis, no? So we already have the angles for P, W, and N is in the new x-axis. So we can now start solving for the summation of forces vertical so that N will not be included, and we can directly solve for W. So summation of forces vertical with respect to the new y-axis is equal to 0. So positive for upward forces. So we will start with, so if the new x-axis is here and the new y-axis is here, so your 300-pound force, it is directed downward to the right, right? So while your P, it is directed upward to the right, and your N, it is directed to the left. Okay, so we will start summing up summation forces vertical with respect to the new y-axis. So we will start with P. So the vertical component of force P, so its angle is 45 degrees from the vertical. So its vertical component will be P cosine 45 degrees. And since it is directed upward, it will be positive here. Now for our 300-pound force, so its vertical component, okay, will be 300 cosine 60 degrees since its angle is from the vertical, no? So it is directed downwards, so it will be negative here. So we can directly solve for P, no? For unknown P pala, no? Not W. So your W is already known, no? So mali yung nabanggit ko kanina. So we can directly solve for P. Okay, here, so this is P cosine 45 degrees minus 300 cosine 60 degrees is equal to 0. So we just transpose 300 cosine 60 degrees to the other side. So that will become positive 300 cosine 60 degrees over cosine 45 degrees to solve for P. Okay, so your P will become 212.13 pounds. So this will be the value of P. Now, to solve for the value of N, we use summation of forces horizontal with respect to the new x-axis. Okay, so this will be our P, the horizontal component is P sine 45 degrees, and since it is directed to the right, it will be positive here. And then we have here 300-pound force. Its horizontal component will be 300 sine 60 degrees since our angle is from the vertical nga, no? So 300 sine 60 degrees, and since it is directed to the right, okay, this will be positive here. Now for our normal force N, it will be negative since it is directed to the left. Okay, and it will be equal to 0. So we can directly solve for N since we already obtained the value of P. So we just substitute the value of P here. Okay, so this will be, so we just transpose the normal force N to the other side, no, and it will become positive, no. And solving for N, it will just be P sine 45, which is 212.13 sine 45 plus 300 sine 60. Okay, let's input that in our calculator. So that will be 409. The answer for N is 409.81 pounds. So this will be the normal force N. So this will now be the answers using solution 2. And it's the same answers with solution 1, no? So, okay, you can also use this solution. Now we can also apply solution 3 for this, since our forces here, we have in this concurrent force system, we have three forces, no? So we can also use force triangle here. So redrawing our three concurrent forces into triangle. So we start with 300 pound. So this will be that 300 pound, and then P. So your P, this is 75 degrees, no, from the vertical. So this is 75 degrees from the vertical, so it should also be drawn 75 degrees from the vertical here, and it is also directed this way, so it will be directed this way as well. Now for the normal force N, so it is directed this way, and this is 30 degrees from the vertical, so it should also be directed this way and 30 degrees from the vertical. Okay, so we will analyze the angles here. Okay, so since your N is 30 degrees from the vertical, so from this vertical, so this should also be 30 degrees. And since your P is 75 degrees from the vertical, so if we subtract 75 degrees and 30 degrees, so it will give you this angle. So this is 45 degrees. And since this is 45 degrees and this is 30 degrees, if we are going to solve for the remaining angle, it will just be 180 minus 30 minus 45 degrees. So it will be 105 degrees. Also, we can also solve this 105 degrees since our force P is 75 degrees from the vertical. So actually, this is also 75 degrees here. If we extend this vertical line, so this force P is also 75 degrees from this vertical, right? And if this is 75 degrees, this straight line is 180 minus 75. That will be 105 degrees. So it depends on you, no, if what's easier for you to solve for these angles, no. Okay, so from here, no, from this triangle, we have all the angles, okay, and we have here one known side and two unknown sides, no. So we can use laws for triangle here. So we can use sine law for this to solve for P and N. So using sine law, this will just be 300 over the sine of the opposite angle, or the angle opposite to 300 pound, which is 45 degrees. So this will be sine 45 degrees. And okay, it will be equal to P over the angle that is opposite to side P, which is 30 degrees. So this will be sine 30 degrees, equal to N over the sine of the side that is opposite to this side. So this is 105 degrees here. So solving for P and N. So for P, that will just be, we will just cross multiply this, no? So to solve for P. So this will just be 300 sine 30 over sine 45, and it will give you 15 square root of 2, or 212.13 pound, no? So that will be the value of P. Now to solve for N, so we just cross multiply this to this, no? Okay, so your N will be 300 sine 105 degrees over sine 45 degrees, and it will give you 409.81 pounds. So this will now be the answers using solution 3. Now let's proceed to sample problem number 4. Determine the magnitudes of P and F necessary to keep the concurrent force system in equilibrium. Okay, so we have here these forces, no? So we have 1, 2, 3, 4, 5 forces here, and the unknown forces is P, RP, and F. Okay, so we will solve this, no? So this system is in equilibrium. So let's start solving this. Again, we are asked you to solve for P and F. this P and this F. Okay, so using solution 1, so this given is already a free-body diagram, no? So we can directly go to solution 1, no? So for summation of forces horizontal, okay, equal to 0 and positive for forces directed to the right. So let's start with 300-pound force. Okay, so this is directed to the right and this is already horizontal. So this will be 300. And then your 200-pound force here, this is actually vertical. So it will not be included in the horizontal summation of the horizontal components. And for P, its horizontal component will be P cosine 30 degrees and it is directed to the left. So it will be negative here. Okay, now for our 400-pound force, its horizontal component will be 400 cosine 45 degrees, and it is directed to the left. That's why it will be negative here. Now for our force F, okay, so its horizontal component will be F cosine 60 degrees, and it is directed to the right. That's why it will be positive here. So this will become our equation 1. Okay, now for summation of forces vertical is equal to 0. Okay, forces upward will be the assumed positive. Okay, so the first force here is 200-pound force. So this is already vertical. So this is positive since it is directed upward. Now for force P, its vertical component is P sine 30 degrees and it is directed upward. So it will be positive here. Now for our 400-pound force, so its vertical component will be 400 sine 45 degrees and this is downward. So it will be negative here. Now for force F, its vertical component is F sine 60 degrees and it is downwards, so it will be negative here. So this will now become our equation 2. So we have two equations, two unknowns. We can solve for the two unknowns. Okay, so we use substitution here. No? So we will solve for the value of P from equation 1 in terms of F. Okay, so from this P, no, in terms of F, we will substitute this to equation 2. So our equation 2 also has force P here. So we will substitute this value here. So this will now become 200 plus P, which is 300 minus 400 cosine 45 degrees plus F cosine 60 degrees over cosine 30 degrees times sine 30 degrees minus 400 sine 45 degrees minus F sine 60 degrees equal to 0. Okay, so from here, the only unknown is F. So we will simplify this. So simplifying this, simplifying 300 minus 400 cosine 45 degrees over cosine 30 degrees times sine 30 degrees. So again, let's input that in our calculator. 300 minus 400 cosine 45 degrees over cosine 30 degrees times sine 30 degrees. So that will be 170. No, that will be 9 point something, no? 9.90576. Okay, so actually, this 173.205 minus 163.9993162. So the value for that is 9.90576. So that's the value that I've input in my calculator. And then we have here F cosine 60 over cosine 30 degrees times sine 30 degrees. So that will be square root of 3 over 6 F. So this will be that value minus 400 sine 45 degrees. This is the value of 400 sine 45 degrees. So if you input that in your calculator, so that will really be the value 282.8427125. And your F sine 60 is square root of 3 over 2F, no? So this is negative here, so it will be negative here. So simplifying this further, we just combine all the constants and all the values of F. Okay, so simplifying this, so for the constants, that will be 200 plus 173.2050808 minus 163.2993162. So that will be minus pa pala, no? Minus 282, minus 282.8427125. And it will give you negative 72.9369479. And for f, that will be square root of 3 over 6f minus square root of 3 over 2f. So that will be negative square root of 3 over 3f. No? So this will be that value is equal to 0. So solving for the value of f, okay, so that if we transpose square root of 3 over 3f to the other side, so it will become positive. So this will be negative 72.9369479 divided by square root of 3 over square root of 3 over 3. So that will give you negative 126.33 pounds. So if the angle here is negative, okay, so meaning to say, angle rather, the force F, no, the answer here is negative, no. So if the answer is negative, okay, so meaning to say, the direction of this force F is actually wrong. So the real direction of this force F is actually opposite of this direction. So the opposite of this direction is this direction. So your F, it should be directed upward to the left. Okay, since it is negative, okay, in our computation. So our F, again, is 126.33 pound, and it is directed upward to the left. So that will be the answer for F. Now, for the value of P, since we already have the F here, okay, we can now substitute this obtained value of f, okay, to our formula here to solve for p. So our f here, our assumption here again is it is directed um, downward to the right, no, our assumption here. So this is a wrong assumption. Oh, so we will substitute negative 126.33 here in this f, no. Okay, so just to make up the wrong assumption. Okay, so this will be 300 minus 400 cosine 45. This will be plus, and our f is negative 126.33 since our assumption is wrong. Okay, and then cosine 60 over cosine 30. Okay, and it will give us negative 53.13 pounds. So our P here is also negative. So meaning to say, the direction of this force P is also wrong. Okay, so its direction should be opposite, no? So it should be directed this way. So it should be directed downward to the right. So our P is 53.13 pound downward to the right. So this should be the values of P and F. So this will now be the answers for these problems. Alright, so we can also solve this using solution 2. So for our solution 2, that is rotation of axis. So we're going to place one of the unknowns in the new either in the new x or y axis. So in this case, we are going to place unknown force P, okay, in the new x axis. So if this is the new x axis, this will be the new y axis. So this is perpendicular to this new x axis. Okay, so from here, we have to analyze the angles. Okay, so for force P, so again, that is already in the new x-axis. Now, for this 400-pound force, as we know that this is 30 degrees and this is 45 degrees, so this will just be 75 degrees. So our 400-pound force here is 75 degrees from the new x-axis. Now, for force, let's say force this 200. Okay, so this 200-pound force. So as we know, your force P is 60 degrees from here. Okay, so as from the given, no, so this is 60 degrees here. And we know that this force P, it is perpendicular to the new y-axis. Okay, so this angle, okay, so this is actually 30 degrees. No? So by the way, this 200-pound force, this is already 60 degrees from the new x-axis. Now, this is 30 degrees nga. This remaining angle is 30 degrees. Okay, so if this is 30 degrees, also, this 300-pound is vertical or perpendicular here, no? So this is 90 degrees. So if this is 30 degrees, this should be 60 degrees. So our 300-pound force here, this is actually 60 degrees from the vertical, no, new y-axis. Okay, now for force F, since we know that this is 60 degrees, no, so this is 60 degrees as well. So this is straight line, so this is 180 degrees. So if this is 60 degrees, if this is 60 degrees, so 180 minus 60 minus 60, so it should be 60 degrees. So our force F, this is 60 degrees from the vertical. Okay, so we already found the angles for each force here in this system. No? So we can now start solving for the summation of forces wherein force P will not be included. So that will be summation of forces vertical with respect to the new y-axis. No? So this is summation of forces vertical primes equal to 0 and positive for upward forces. No? So here, this 200-pound force, this is already directed upward to the left, no, with respect to the new x and y axis. Your force P is directed to the left. This 400-pound force this is directed downward to the left. And then this force F, this is directed downward to the right. And this 300-pound force, this is directed upward to the right. Okay, so for summation of forces vertical primes equal to 0, so we will start with 300-pound force. So for 300-pound force, so its vertical component will be 300 cosine 60 degrees, and this is upward. It will be positive here. Now for this 200-pound force, its vertical component will be 200 sine 60, no? So it will be sine 60 degrees if we're going to use this 60 degrees, no? So this is sine 60 degrees and this is directed upward. It will be positive here. Now for force 400 pound here, okay, so this is its vertical rather. Its vertical component is 400 sine 75 degrees. And this is directed downward, no? So it will be negative here. Now for force F, its vertical component, since the angle is here, so it will be F cosine 60 degrees. And this is directed downward, it will be negative here. So we can directly solve for F. Okay, so solving for F, it will just be, we just transpose F cosine 60 degrees, negative F cosine 60 degrees to the right side. So it will become positive. And solving for F, that will just be 300 cosine 60 degrees plus 200 sine 60 degrees minus 400 sine 75 degrees over cosine 60 to solve for F. And that will give you negative 126.33 pounds. So again, since your F is negative here, so we have the wrong assumption here. So our F should be 126.33 opposite of this direction, no? So it should be directed it should be directed upward to the left, no? Okay, so that will be the value of F. Now, to solve for P, so that is just summation of forces horizontal primes equal to 0, positive for forces directed to the right. Okay, so we will start with 304. So the horizontal component of this 300-pound force is 300 sine 60. This is to the right, so this will be positive. And then for 200-pound force, its horizontal component is 200 cosine 60 degrees, no? So it is directed to the left, it will be negative here. And for force P, so this is already horizontal, so this is directed to the left, it will be negative here. Now for 400, so its horizontal component is 400 cosine 75 degrees, and this is directed to the left, it will be negative here. Now for force F, its horizontal component will be F sine 60 degrees, and this is directed to the right, it will be positive here. So this is equal to 0. So since we have already solved for F, okay, we can directly solve for P. Okay, so solving for P, we just transpose negative P, no, to the other side so that it will become P, and we can solve now for so this will be 300 sine 60 minus 200 cosine 60 minus 400 cosine 75 Okay, plus F, our F is 126.33 sine 60. Okay, so it will give us, so our P now here will be negative 53. Okay, negative 53 point, um, mm, negative 53 point. So again, our F here, okay, so what we're going to use here is negative. Okay, negative 126.33 since our assumption here is actually wrong. No? So our F should be directed upward to the left. No? So it should be negative here. Okay, so it will be negative. So it will give you negative 53.13 pound. No? So again, your P is negative. So the assumption for P here is wrong. So your P, it should be directed downward to the right. So this will now be the value of P. So this will now be the answers using solution 2. Now using solution 3, that is force triangle. Okay, so this cannot be applied, okay, to this force system since this force system has four, I mean, more than three, no? It has more than three forces. So force triangle cannot be applicable for this force system. Now let's proceed to sample problem number 5. So determine the magnitudes of alpha and theta necessary to keep the concurrent force system in equilibrium. So we have here 40-pound force and 20-pound force, alpha from the horizontal, and 30-pound force. This is theta from the horizontal. Okay, so let's start solving this. So for our solution 1 for this, so this is summation of forces horizontal is equal to 0. Okay, positive for forces directed to the right. So this will be 40 minus 20 cosine alpha minus 30 cosine theta is equal to 0. So this will be our equation 1. Now for summation of forces vertical is equal to 0, positive for forces directed upward. Okay, so this will just be 20 sine alpha minus 30 sine theta is equal to 0. Okay, so this will now be our equation 2. So we have here two unknowns, alpha and theta, and we have here two equations. So we can solve this. Okay, so we will use substitution here. So we solve for alpha from equation 1. So your alpha will be, we can transpose 20 cosine alpha to the right side. So it will become positive 20 cosine alpha. And what will remain here is 40 minus 30 cosine theta. And we divide both sides by 20 so that only cosine alpha will remain in the other side. No? And solving for alpha, it will just be arc cosine of 40 minus 30 cosine theta over 20. So this will now be the value of alpha in terms of theta. So now we are going to substitute that alpha to the alpha in the equation 2. So this is our equation 2. So we will substitute here our alpha. So this will now become 20 sine, and our alpha is arc cosine of 40 minus 30 cosine theta over 20 minus 30 sine theta is equal to 0. So from here, okay, so we have no choice here, no, to solve this easily, no. So we can shift solve this, no. So this solution 1, this is not actually the appropriate solution for this, no. If we use this, no, we will really have to use shift solve, no. So to solve for the theta, okay. So if we use shift solve, so that will be 20 sine of arc cosine 40 minus 30 cosine theta rather over 20 minus 30 sine theta is equal to 0. So it will give us the answer for theta will be 28.96 degrees. So that will now be the value of theta. Now, since we already have the value of theta, we can substitute that theta, okay, to our formula for alpha. So, to solve for alpha, no? So, this will be arc cosine, okay, of 40 minus 30 cosine the theta that we obtain, okay, over 20. So it will give us 46.57 degrees. So that will now be the value of alpha. No? So from the figure, so our theta is 28.96 and our alpha is 46.57 degrees. No? So this can be validated naman. No? So this can be logical naman, no? These values. Okay, so this will now be the value of theta and alpha. Okay, so for our solution 2, okay, so it will be useless since the unknown quantities are not forces but angles. Okay, because in solution 2, we are going to place unknown force, right, in one of the new x or y axis, no? So here the unknown is not force, no? So the unknown here are angles, no? So this solution, no, solution 2 or rotation of axis will be useless. So we will not use that. Now for solution 3, okay, so we will use force triangle here. Okay, so connecting these three forces. Okay, so your 40 pound is directed this way and this is horizontal. Okay, now for 20-pound force, this is directed this way and this is alpha from the horizontal. And our 30-pound force, this is directed this way and it is theta, okay, from the horizontal. So this is theta from the horizontal. So from this horizontal, this is also theta. So from here, we have here the the sides, no, all the sides of this triangle are known and the angles here are unknown. So the law of triangle that we can use here is cosine law. Okay, so to solve for theta, okay, to solve for theta, let's say for theta, we are going to use this side of the triangle, no? So using cosine law, that will be 20 squared is equal to 30 squared plus 40 squared minus 2 times 30 times 40 times cosine theta. So we can solve for theta here. Okay, so solving for cosine for theta here, no? So it will just be arc cosine of 900. So that is the 30 squared, no? And then 1600 is 40 squared and 20 yung 400 is 20 squared, no? So it was transposed, that's why it is negative here over 2 4. So your 2 4 here or 2400 is the 2 times 30 times 40, no? Okay, so solving for theta, it will give us 28.96 degrees. So as you can see here, this is the appropriate solution for this problem. No, we can use solution 1, but the thing there is that we have no choice but to use ship solve. No, so but here in force triangle, no, using solution 3, so our theta can be directly solved here, right? No, okay, so this will be the theta. And also for our alpha, so to solve for alpha, we are going to use this side as the quantity in this side. No? So this will be 30 squared is equal to 20 squared plus 40 squared minus 2 times 20 times 40 cosine alpha. So solving for alpha, so that will just be arc cosine of 400 plus 1,600. So I already simplified this, no? So our alpha here will be 46.57 degrees. So this will now be the answer for alpha. Okay, so for sample problem number 6, the cylinders below have the indicated weights and dimensions. Assuming smooth contact surfaces, determine the reactions at A, B, C, and D. So we have here two cylinders, no? So this is the larger cylinder. Okay, and this is the smaller cylinder. Okay, so these two cylinders, okay, they are for this, let's say for this bigger cylinder, no, this is supported by this surface here and this surface here, and this is actually also supported by this smaller cylinder here at this contact, no? Okay, and also for this smaller cylinder, so this is supported by this surface and this is actually also supported by this larger cylinder at this point of contact, no? Okay, so from here we're going to solve for the reactions at A. So there will be a normal reaction here For the reaction at B, also there will be a normal reaction at C. So also there will be a normal reaction here at the point of contact of the larger and smaller cylinder. And we also have here a normal force at point D, no? Okay, so let's start solving this. Okay, so to solve for the reactions at A, B, C, and D, so let's first draw the free body diagram of the cylinders. So for the free body diagram of the big cylinder, okay, so for the surface here, so there's a point of contact here. Okay, so the normal force will be applied at that point of contact, and it is perpendicular, okay, to this surface. So it will be horizontal, no? We will name that normal force as NA, no? This is the normal force applied at point A. Now for normal force at point B, so again, the point of contact is here, so it will be applied here. Okay, and it should be applied perpendicular to the surface, so the surface is horizontal. So this normal force at point B should be vertical, no? And we will name it as N sub B, no? Now for the weight, no? For the weight na of the larger cylinder or the big cylinder, so its weight is 400 pounds. So it will be applied here at the center of gravity or at the center of this circle shape, no? Okay. So also for the point C, no? Here at point C, this small cylinder will also provide a support, okay, for this larger cylinder. Okay, so it will provide a normal force. Okay, so if we are going to put here a line, okay, tangent at this point, no? So a tangent line actually touches the curve at one point, right? So if we have here a tangent line, so this normal force will be perpendicular to that tangent line, and this should be this should be directed this way, no? Okay, so this will be N sub C. Okay, so if you're going to extend this NA, okay, this NB and this N sub C, no, if we extend their line of actions, they will all meet at this point, no? So this is actually a concurrent force system, no? Okay, so this N sub C, this is angle theta, okay, from the horizontal. So we don't know yet the value of this theta, no? So okay, so let's now draw the free body diagram of the small cylinder. So our small cylinder is this cylinder, no? So let's apply this, okay, or let's construct its free body diagram. So its weight is 200 pounds, so it is directed or applied here at the center. Okay, now for NC or the normal force here at C, at point C, so this reaction, okay, that is in the free body diagram of the big cylinder, if we transfer this in the small cylinder, no, it will be directed oppositely. Okay, so this N sub C, it will be directed this way, no, at point C. And if we extend this, this will also be theta from the horizontal, just like here, no? So if this is theta from the horizontal here, it should also be theta from the horizontal here also. Okay. Now for um it's for the point of contact of the surface to this small cylinder here. So this will provide a normal force here, and this normal force should be applied at the point of contact of the small cylinder and the surface, and it should be applied perpendicular to the surface. So if the surface is vertical, so this normal force will be horizontal here, no? And we will name this as ND. Okay, so from here, we should start with the free body diagram, okay, that only has two unknowns. Okay, so we have to start solving, okay, here, okay, in the free body diagram of the small cylinder, since there are just two unknown forces here, N sub C and N sub D. So we cannot start here in the free body diagram of the big cylinder because there are three unknowns here. So we can only generate two equations. So we have to start with the system that only have two unknowns. Okay, so let's start solving this. Okay, so before we can start solving for the free body diagram of the small cylinder, we have to solve first for this theta. Okay, so this is unknown, so we have to solve this. So we can actually solve this using the geometry of the figure. So as we know that the larger cylinder or the big cylinder, its radius is 2 feet, okay, and the radius of the small cylinder is 1 feet. So from here, this theta, okay, actually, it can be obtained, okay, from this triangle form. Okay, so this triangle, this side of this triangle, it will just be the radius of this large cylinder and the radius of this small cylinder. And this is 2 and 1. So this will be 3, right? And if we are going to have this horizontal line, no, and this vertical line, so this is 90 degrees here. So this will be a right triangle, no. So we can actually solve for this um, adjacent side of this triangle, no? So since we know that this is 5.6 feet, no? This from here to here, this is 5.6 feet, and we know that this is 2 feet, okay, and this is 1 feet. So subtracting 2 feet and 1 feet from 5.6, we can actually solve for this, right? And 5.6 minus 2 minus 1, that is actually 2.6. So from this triangle form, okay, so again, this side will be 3 feet. So this will be the theta, and this side of the triangle is 2.6 feet. So from here, we can actually solve for theta. So we can use SOHCAHTOA here, so, since this is a right triangle. Okay, so we can use, since the available data here is adjacent side and hypotenuse, so we can use ka, adjacent over hypotenuse. So cosine theta will be equal to 2.6 over 3. And solving for theta, that will just be arc cosine of 2.6 over 3. And that will give you 29.92643 degrees. So that will now be the value of theta. So we can now start solving for the free body diagram of this small cylinder, no? And we're going to use solution 1, so that will be summation of forces. Let's start solving for summation of forces vertical. Since one of the unknowns is in the horizontal, so this ND, no? So this is in horizontal axis, right? So if we start solving for the summation of forces vertical, it will not be included, so we can directly solve for N sub C. So summation of forces vertical is equal to 0. So positive assumption for upward forces. Okay, so N sub C, its vertical rather, its vertical component is N sub C sine 29.92643 degrees. Okay, and your 200-pound force, this is already vertical and this is downward, so it will be negative 200 here. It's equal to 0. So solving for N sub C, so that will just be 200 over sine 29.92643 degrees. So that will give you 400.89 pounds. So this will now be the reaction at point C. Okay, now we can solve for the for ND or N sub D, no? So we use summation of forces horizontal here is equal to 0. So positive 4 forces directed to the right. So N sub C, okay, its horizontal component would be N sub C cosine 29.92643 degrees, and N sub D is already horizontal, so it will just be negative N sub D here since it is directed to the left. So it will be equal to 0. Since we already have N sub C, we can solve directly for ND or N sub D. So that will just be 400.89 cosine of 29.92643 degrees. So your N sub D will just be 347.44 pounds. So this will now be the reaction at D. No? So this will now be the answer. Now, to solve for the remaining reactions, that is reaction at A and B. Okay, so we will use the FBD of the big cylinder. So we have already solved for the value of N sub C. Okay, so we can now start solving for N sub A and N sub B using solution 1. So we can start summing up forces, either forces horizontal or vertical. Okay, because if we sum up forces vertical, n sub a will not be included since n sub a is in the horizontal axis. Okay, and if we sum up forces horizontal, n sub b will not be included since n sub b is in the vertical axis. No, so either way you can start solving. Okay, so here we start by solving summation of forces vertical is equal to 0. Okay, and upward forces will be positive. Okay, so it will just be n sub b minus 400 minus n sub c sine 29.92643 degrees equal to 0. So we already obtained the value of n sub c from our previous um, computation. So we can directly solve for nb. So your NB will just be 400. So we transpose 400 plus 400.891922 sine of 29.92643 degrees. Okay, so that will give us 600 pounds. So that will be the normal reaction at B. So this will now be the answer. Now for summation of forces horizontal, so positive for forces directed to the right. Okay, so that will just be NA minus N sub C cosine of 29.92643 degrees equal to 0. So we already obtained the value of N sub C, so we can directly solve for N sub A. So that will just be 400.891922 cosine of 29.92643 degrees. So your N sub A will just be 347.44 pounds. So this will now be the value of N sub A. Now, for solution 2 or rotation of axis, so we don't need to use this because the unknown quantities, okay, in the free body diagram of small and big cylinder, so the unknown quantities are already in the x-axis. So in the small cylinder, no, the unknown quantity here is already in the x-axis, so no need to rotate the axis. Also for the free body diagram of the big cylinder, the unknown forces here are already in the vertical and horizontal axis now, so no need to rotate the axis. Also, for solution 3, we can only use force triangle for the free body diagram of the small cylinder since there are 3 forces here. Okay, but for the big cylinder, there are 4 forces here, so we cannot apply force triangle for the big cylinder, no, for the free body diagram of the big cylinder. So using solution 3 for the free body diagram of the small cylinder, so this will be the triangle form. So our 200 pound is vertical and it is directed downward, and then n sub c, it is directed this way, and this is theta from the horizontal. So this will be theta from the horizontal, and n sub d, this is actually horizontal, no, and it is directed this way, so it should be directed also this way. So from here we can see that this is a right triangle, no, and we already know the value of theta, so we can solve for ND and N sub C. So we can use SOHCAHTOA here to solve for NC. Okay, what we need here is hypotenuse and opposite side, so we can use sine theta for that. Okay, so sine theta is equal to 200 over n sub c. Okay, and our theta is 29.92643. So solving for n sub c, that will just be 200 over sine of 29.92643 degrees. So that will be 400.89 pounds. So for n sub d naman, okay, so what we need here is adjacent side and opposite side. Okay, so we can use TOA, tangent. So that will be tangent theta is equal to 200 over n sub d. And solving for n sub d, that will just be 200 over tangent of 29.92643 degrees. So that will give you 347.44 pounds. So this will now be the answer for reaction at C and D, okay, using solution 3. So we have already solved for the reactions at A, B, C, and D. So this will now be the answers for this problem. So that concludes this discussion. So I hope that you learn, and I hope that you attain the learning outcomes for this topic. So see to it that you answered the course material assessment task for this topic, and it will be submitted on our next meeting. So happy studying, class. Keep safe and God bless. Bye-bye.